Okay, so today we are going to be, let me just close some stuff, clean up a little bit here. Um, we're still sort of in the design phase. We'll be probably working on some Solidity by the end of this stream, but we're still sort of starting from the ground up here and getting our head wrapped around, our collective head wrapped around what it's actually going to take to build our project. So again, to recap, I'll just go ahead and open up the my little document here. Where did it go? Oh yeah, we're talking about it in Project 6, by the way. So just to recap what we're actually going to be doing here, we have this burnable payment contract, which of course I've built the interface to it on toastycoin.com, and I'm actually going to be using the beta version of the contract, which I'll get into the differences there in a moment. But here's the code of it as well, and we're going to be using these same contracts sort of as a primitive to facilitate a crypto to fiat decentralized trade mechanism. And I talked about that in the last seminar, so you can go check that out if you want more details. The first thing that I want to do is go through, well, I'll just go through this outline here. So first we're going to just take a look at the burnable payment code here. You can see it's certainly longer than any other contract we've worked on. A lot of these functions are still quite simple, and in fact, I mean, logic in general is simple. There's just more of it than we've used before. We also have it's a state. We're going through actually a state here that we haven't done something like that before either. But anyway, we'll go through that code. Then we'll talk a little bit about some additional data that we'll need to store beyond what the code here directly explicitly supports if we want to actually do the if we want to support the use case of crypto to fiat trades. Then we'll talk about designing a new contract that will actually sort of manage all of this, and I guess you could say it'll fill in some of the gaps for our use case. I mean, first of all, the additional data that we talk about on the second point here, we will probably capture some of that in this new contract. And the new contract also is going to capture a fee from the user and send it to our server, which will, because our server is just a centralized, it's just going to be a cloud server somewhere, and that's going to manage email notifications. And if we don't have some sort of income secured for that server, then it's not making any money, and it's just we just can't depend on it economically speaking to last. So we at least want to design a system with some sort of income for the server. So our new contract is going to do those two things. It's going to, I'll just add those in here. It's going to encode more data, and it's going to secure a fee for our server. And then however much time we have after I've talked a bunch about all that stuff and gone over everything, we'll actually start designing that new contract. And then just sort of a disclaimer on the seminar today. As with yesterday, I'm sort of bringing you guys along for the ride of designing this, so my apologies if it seems a little bit rambly, but I'm just trying to design this from the ground up, and hopefully you guys can find value in that as we sort of take sort of a vague idea and bring it closer and closer to reality. Okay, so first we're just going to take a tour through the code here. Let's see, I am going to just ignore all these comments. I've talked about burnable payments a couple times before, and this is just going through the general, the way it works. Now this burnable payment, if you go to ToastyCoin, as I said a little earlier, there is a beta, and then there's, if you just go to it initially, it'll tell you that you're using the old version and you can use the beta. The difference between the beta and the older version is that when you create a burnable payment, you can actually create it as a worker now. You have this option. Before you could only create it as a pair, and the way that works is you'd put in your address, the title, and some more information. You put in how much money you want to pay for the service and how much money the worker has to put in, then your auto release timer. And this beta version, this new version of the Burnable Payment, actually allows you to open it as a worker. And what that will let you do is, you can see the form is very much the same, but now in this case, when you click create, you're actually going to be putting in the service deposit yourself preemptively, and you're going to be describing the service that you're willing to do. So rather than asking for some service, you're sort of putting yourself out there, almost sort of making your own vendor stall out on the blockchain. And so you put your service deposit in there initially, and then you actually you specify what the payment amount needs to be. And then it's the payer that actually finds you and signs up. So in whichever way you start this, whether you started as a payer and you're waiting for a worker, or you started as a worker and you're waiting for a payer, once the second party joins and commits, it'll move to the committed state, and it'll behave just like a regular burnable payment, where you have a payer and a worker, and the payer can determine whether the payment is burned or released, and the worker is expected to do some work. So yeah, just to summarize, the main difference between this beta version of the new Burnable Payment and the older version is that you can sort of begin it in a new way. And so I'll note those changes in the code when we get to them. But that's what that difference is there. Okay, so let's see here. And probably when I compile this, we'll get some errors because I changed. This used to be just Solidity 4.2, and I changed it to Solidity 4.2.4 because it's been a while since I actually changed this code, so we'll probably see some errors there. But okay, so let's see. I wonder if I should just go through this from top to bottom. I'm gonna skip the factory, or I guess I'll just talk about it briefly. The factory is just it just has one function, and you call it to create the burnable payment. You can see it's calling the right here. It's actually creating the burnable payment, which we define down here, and then it also adds it to the list of burnable payments, which is useful for when a client wants to go through and look for all of the burnable payments. So that's really what the factory does, and we have an event defined here that gets emitted. Which also helps for if an interface wants to track the burnable payments that are created. And this is just a simple getter that gets the length of this array here. So okay, on to the actual burnable payment. We have a lot of members here, just variables of the burnable payment state. We have a title, which is actually stored in the burnable payment. We have a payer and a worker, and a burn address is just 0x0. That's just where the money is sent. And we'll see later that there's a specific burn method that actually uses that burn address. Just makes things more explicit when we burn Ether. This Boolean recovered. When you create this burnable payment, whether you create it as a worker or a payer, when it's in the open state and you're still waiting on that second party, you can cancel the payment and get the money back. And that actually destroys the burnable payment, but it also sets this recovered Boolean to true. And that might seem a bit silly to you because you're thinking, well, if you're suiciding the whole contract anyway, then what's the point of setting this to true? It's just another way to indicate to any client that's watching it, because they'll probably see this recovered turn to true before the contract disappears completely, so they can actually handle that logic. React more intelligently to the fact that it's been deleted. These three variables are just, as I say here in the comment, these will track but not influence the burnable payment logic, and they're pretty self-explanatory. So how much has been deposited, how much has been burned, and how much has been released. And I guess as I go through this, I'll just go and load up a burnable payment on the interface so we can just sort of see how this looks. So again, these three variables here, we can see them actually outputted here. So how much has been deposited, how much has been released, and how much is burned. Those are just direct reflections of these variables here. And by putting these variables into the contract code itself, it just makes it a little bit easier for the interface to output these. If I didn't have these explicitly tracked like this, then our interface here would have to iterate through the entire history of the burnable payment and sort of tally it which would be a little complicated. Just got a big headache. Let's see. So the commit threshold, in the earlier version of the burnable payment, I had called that the service deposit. In this case, I had to rename it because when the burnable payment is opened, it could either be opened by the payer or the worker, and they're waiting for that other party. And so this is the amount that other party has to put in. So again, if you create this as a payer, you fill all this out, the value of that commit threshold is going to be the service deposit. So as the payer, you'd put in some payment amount and you'd specify how much they have to put in. So that'll be the service deposit here. If you're the worker, then you actually put it in a service deposit yourself and you're specifying how much the payment amount has to be. So in either of those cases, this commit threshold is how much the other party has to put in, whether you're a payer waiting for a worker or you're a worker waiting for a payer. And that comment sort of just phrases that thing a different way. And once that party comes in and puts in that commit threshold, then the burnable payment moves from the open state to the committed state. Auto release interval, that just has to do with the auto release. Obviously, when you create one of these, you can say how long your auto release timer is supposed to be, and I won't go into the mechanics of that too much quite yet, but that's just tracking what that interval is actually supposed to be. And this auto release time, of course, is related to the auto release interval. You can read these comments if you want more details, but the interval is the value, for example, 2 weeks that you put, and then the auto release time is the actual Unix timestamp that the auto release should be triggered, assuming that it's not delayed by the payer. Okay, and then we have a state. I like using a state enum in a lot of my contracts. And here we've defined this enum, and here we've actually made one. So there's 4 options here. In the original burnable payment, there were not 2 open states. There was only 1 open state, and it was assumed that it was payer opened. But now, since you can open it as a payer or as a worker, there's 2 separate states for that. So there's a payer opened and a worker opened, which are similar. They're sort of mirror images of each other. And then there's a committed, which means that there's 2 parties, and also means that the payer can no longer recover the money. They can just burn or release. And then there's closed, which is pretty boring. It just means that all the action is completed. There's no more money left in the burnable payment. Then we have some modifiers. We have a modifier to check if it's in a given state, again, using this enum. And then we have a modifier specifically for in the open state that is now striking me as actually redundant. So I might even want to, it's not redundant because it's specifying that it's in either open state. So as you can see here, it's requiring that the state is either in payer opened or the state is in worker opened. So that's not redundant because you couldn't really express that in terms of this in state here. Okay, only payer and only worker, it's pretty self-explanatory. Only payer or worker, also sort of self-explanatory. And this modifier only creator while open, so that just means, again, because you can open this as a payer or as the worker, either way, when you create this, which we'll get into the constructor here in a little bit, but the person who creates it is called the creator while it's open, and so this modifier just is specifying that only the person who created it can do it, and only while it's open. And then that's just expressed in these various require and if else. Okay, we have a bunch of events here. I don't need to go over all of those, but you can just look at the names here and see that effectively there's an event that's emitted for every action that is noteworthy. In fact, I think every single external method here it probably triggers one or more of these events. Okay, so here's the constructor. Man, I don't want to spend too much time going through the code because I do have other things I want to go. So I'm going to go pretty quick. Let me know on the Slack if you guys have any questions. Okay, that's just an event which I can already tell I'm going to have to put an emit here. This is a change. As I said earlier, I'm using a different Solidity compiler now than when I wrote this. And the earlier one, you did not have to say emit. You could just call the name of the event. So that's a good change now because it just makes it more explicit. With this, without this event here, it's not immediately obvious that this is an event being emitted, and this just makes it clearer. So I'll have to change that as I go, probably with a few other things, because we're using a different version of the Solidity compiler, which I guess means we're going to be recompiling this and starting a whole new factory contract. A brief note on that, I guess, while we're here. The way that ToastyCoin tracks all of these payments, so the whole reason it can actually make a list of all these payments is because it's watching. If we go back to the main page here, I guess I should click on the beta since that's what we're using, but it's watching the factory contract, specifically this contract at this address with this code. And so when we redeploy this, when I compile it and redeploy, we will be deploying a new factory contract. And so when we create burnable payments through it, the ToastyCoin won't actually it won't track those because it's only watching this this specific factory contract. There's not really any easy way to watch for a specific type of contract other than watching a specific factory contract. So that's fine. I mean, it doesn't really strike me as good or bad, but it's just something to note that as we create this new factory contract and redeploy it, ToastyCoin will basically be completely unaware of the new burnable payments that we're creating, unless I, as the I guess the owner of ToastyCoin, go and I add in some logic to track that new contract. Okay, all right. In any case, so let's see here. Now here, this is something we'll have to look at a little later because, as I see here in the comment, well, first of all, this is an event, so I should say emit. We're emitting the event funds added, and we're logging the transaction.origin as the person adding the funds, rather than we have, of course, the option that we're more familiar with is message.sender. And the difference between those two is that transaction.origin actually refers to the calling key pair, you could say. So it's an actual user that's calling this, and that user could be a script or something, but it's not a smart contract, it's a key. Transaction.origin is the person calling it, and message.sender is really just the last contract that called it. And there might be ways that you could affect that, but in any case, if we just leave this as message.sender and we don't address that in some other way, then this funds added will log the message.sender as the beneficiary of these funds, and that will actually just be the factory contract because that's the one that's actually creating this burnable payment. So that's something that we'll have to keep an eye on. And just be aware of, because we are going to be building another, yet a third sort of, I mean, there's two contracts here. There's the burnable payment, there's the burnable payment factory, and then we'll be building yet a third one that sort of administers all of that. So we'll have to keep in mind this sort of complicated question of, well, specifically, how does the burnable payment know that well, here, let's just get down here a little bit. Here we're assigning either the payer or the worker to the creator, well, I guess that's just passed in as an argument, so that's not really an issue there. I was going to say we have to worry about whether we use message.sender or transaction.origin to assign the payer or the worker, but since it's just passed in as an argument, I guess we don't need to worry about that. Okay, well, all right. Moving on. Okay, so we just say if the message.value is greater than 0, so if there's some amount of ether actually sent with the creation call, increase the amount deposited. Again, that's just a tracking variable. Emit funds added. we set the title to the title argument. That's pretty clear. By the way, title is probably where we'll be encoding some of our data. So, I mean, for one thing, we'll probably tag it in a specific way that lets the server know that it is specifically a offer of selling Ether and not just any old general burnable payment. And then we have a Boolean when you call this of payer is opening, and that is true if we're using it in the original way, which is the payer begins the burnable payment. And if it's false, it means that the worker is actually opening. And so you can see we handle that differently. If the payer is opening, then that means the payer is the creator, or the creator becomes the payer, would be a better way to say it. And if not, then the creator becomes the worker. And then we set the state appropriately, either to payer opened or worker opened. We set a couple more variables here, and then we just say, when you create this, you can pass in at the end here an initial statement. Whoa. And then so here we just say, well, if the length of that if there is an initial statement at all, then we just call the well, again, I should put an emit here. We call either the worker statement or the payer statement, depending on how this thing is being opened. Okay, so that's the creation. Add funds. That's just a function for adding more funds if you create a burnable payment and you want to put more money in there. So like if you make a payment for some service and no one's biting, then you might want to put more money in there to further entice people. I don't think I'm going to go through this code line by line because we're already 27 minutes into our hour-long seminar, and I did want to get to more of this stuff. So I'm going to start going a little bit faster here, and I guess I'll also be, whenever I see an event, try to add this emit here. Let's see. So add funds, yeah, as I said, well, it's only the payer, the worker, and you can just add more funds to contract. Recover funds, this is one of the ones that's using our only creator while open modifier, and this just sets recover to true. It emits funds recovered, and then depending on if it's payer opened or worker opened, it self-destructs to the payer or the worker. This self-destruct function is a built-in Solidity function. It takes as an argument an address, and it will basically destroy the contract and then send any ether that it contains to the address that you pass it. So reading this line in English doesn't really make sense. It almost looks like we're trying to self-destruct the payer. What's actually happening here is we're just calling the self-destruct function, which destroys the contract, and as an argument it says, well, where do you want me to send any of the money that's left over? And so we're saying it, okay, if it's the payer opened it, then send it to the payer, and if the worker opened it, send it to the worker. Okay, now this commit function, I think I will go through this line by line because it's sort of one of the central functions of this contract here. It's pretty essential to understand what's going on here. First of all, before getting into the code, I guess this commit function, and really this whole thing could do with some more comments, but this commit function is how the contract moves from an open state to the committed state. And so one of the requirements of that is, of course, it has to be in the open state. And then also we have a requirement that the value sent here with the function call is equal to the commit threshold. And so that's just making sure that if you're a payer and you open it up with with 1 ether, and you want the worker to have to put in 0.1 ether, then this requirement statement is just making sure that they've actually done so. Let's see here. If the amount that they've sent is greater than 0, because it is possible to have a commit threshold of 0. I don't really know why you'd want to do that, but in any case, if the value is greater than 0, then you want to emit funds added, and then add the amount to the amount deposited. Let's see here, and then again, depending on whether it's payer opened or worker opened, you want to set the other party to the message.sender. So whoever's calling this function, they're only going to call as sort of a consequence of calling this commit function. They're moving it from an open state to a committed state, and they're also assigning themselves as the second party. So if it's a payer opened burnable payment, then we want to set the worker address. We want to set the worker to their address. And if it's not payer opened, in other words, if the state is worker opened, then we want to set that the message sender to the payer role. And finally, we change the state to state.committed. We can emit this. This is just emitting an event saying that the state has changed. And then we set the auto release time. And again, there's two sort of auto release variables that we have in the contract. There's the auto release interval, which is, for example, 2 weeks. And then there's auto release time, which is a specific timestamp that indicates specifically when the auto release will run out. And so here we just set that to the auto release time should obviously be now plus 2 weeks or 1 day or whatever you've set that interval to be as the payer. So yeah, that's the commit function. And again, just the overview here is that it can only be called by someone who puts in whatever the commit threshold is, and then it does a few things at once. It moves the payment in from the open state into the committed state, which as a consequence prevents the payer from, I should say the creator from recovering funds, because as you can see that this we're enforcing here that it has to be open. So by committing, they're preventing the first party from recovering the funds, and they're also making sure that they are locked in as that second role, whether that second role is the payer or the worker. Yeah, and then we're also moved to the committed state. Okay, these next 4 functions here are, we have an internal burn and an internal release and a release. I'm trying to remember exactly why I split these up. Let me just think about that for a second here. Well, okay, so the internal burn, it has no checks on the outside. So when we call internal burn, it'll work for sure. And by making it private, we make sure that nobody else can actually call this. Another change I should be making here is changing in the internal and external words were added since I wrote this. So I should really be using these. You can use, there's still uses for private and public, but in most of these functions, I'm using public and private because that's all I had, when really now that we're using the newer version of Solidity, it should be external and internal. Anyway, so just looking at the internal burn and the burn, they each take an amount. This external burn function is, it stipulates that it has to be in the committed state, also that only the payer can call it, and then it just calls internal burn here. And then internal burn actually does this burning process. So here's our burn address, which we defined earlier. It's just 0x0, and we're just transferring amount to that address. Pretty straightforward. The rest here is just sort of it's tracking some variables right there, emitting an event, and then it also checks to see if the balance of this contract is 0. And another change is that we actually have to do something like this. And that's, again, because we have a new version of Solidity. You can't just say this.balance anymore. You have to say address this.balance. In any case, if the balance has been set to 0, then we want to say the state is closed, and then we want to actually emit the closed event. So that's those two. And then these a release and internal release are very similar. The only difference is that where when we burn, we're transferring to the burn address, and when we release, we actually want to transfer to the worker. And otherwise, the structure of these is the same. And once again, this should be internal, and this should be external. And I want to emit these rather than just, yeah, okay. And I think the rest of these functions are pretty simple. And actually we're already at the bottom of the contract, so that's good. It didn't take too long. Log payer statement and log worker statement, those are just event emitters. And if we go look at our contract here, that's what That's what generates these things right here. So there's no logic there. The only thing we want to make sure is that only the worker can call the log worker statement, and only the payer, and only the payer can call the log payer statement. That's really the only logic we have here. And again, these should be external. External. Okay, and then these two functions have to do with the auto release. The payer can delay the auto release. Only the payer can. They can delay the auto release as many times as they want, and we're just repeating the same line that we wrote here, which we had in the commit function, which is just to say that okay, we're setting the auto release time, so when the auto release will become available to the worker, we're setting that to now plus the auto release interval. And then we emit an event, just indicating that that happened. And every time there's an event here, oh, I should put an emit in front of these too. Every time I'm emitting an event, I have my interface here catching the event. And this whole list of events, this is generated entirely from these events that I'm emitting. And then the only extra thing I have to do is just take the arguments and make it human readable. So, 20 mil ETH deposited by this, rather than just outputting the variables straight. But anyway, those are just pretty much a straightforward grab of the events that I'm emitting from the contract. Anyway, and now trigger auto release, only the worker can do this, and it has to be in the state of committed, which is also a requirement of the delay auto release. In both cases, it has to be in the committed state, but here's where we actually enforce that requirement having to do with the auto release time. So here you can see we're just requiring that now is greater than or equal to the auto release time. Otherwise, this will fail. And then if that doesn't fail, then we're going to emit the auto release triggered, and we will also internal release. And so okay, so here is why I built the internal release and the release functions separately, so that now, because our logic sort of says that a release should happen, even though we don't have the payer's approval, which is normally the requirement of the release. That's why it's useful to have separate out the internal release and the release, because this sort of external function here called release, in this case we do want to enforce that it's in the committed state, it's only the payer, etc. Then finally go and actually do the thing. But we don't always want to enforce that, and specifically when the worker triggers the auto release, we don't want we're explicitly ignoring the payer's wishes because the auto release has come. And so by defining this internal release separately and marking it as internal, then we can make this this function available to the rest of our contract and skip all of the checks, and we don't have to repeat code. So that's why I have a separate internal release and a release. I don't think I use the internal burn anywhere other than in the burn function, but I didn't know that when I designed it, and part of me, I feel like it's good to have similar structure with the release and the burn. Anyway, so yeah, and then this get full state is just a getter, and as you can see, it just returns the full state of the contract, and that's just to make it easier on the interfaces, so that you can call this function one time and you'll get basically everything that you want to know about the contract back in a single call. So that is the Burnable Payment contract. So that was a lot of talking. I can go ahead and cross this off. Now, our next item here, we're going to have to go back to sort of the design of our project here. So we want to leverage this primitive here. I've proven that it can work. You can go through and look at my Burnable Payments here, either on the beta or, well, actually, I don't think I ever tried the beta very much. So some of these are open, and if you go to the earlier, or the more stable version, I should say, and you go to browse, you can look through these, and you can see that about 2/3 of them succeeded, and some of them have half success. But I learned a lot, and I think I've proven, at least to myself, that that the functionality here is sound. So, given that this contract works, and specifically given that it worked for the this transfer one right here, deposit the Ether into my bank account, which I went over that last last seminar, I should say. The goal here is to use this to expose the specific use case of doing that decentralized crypto transfer again. So one thing we will do now is to go over the extra information that's needed, given that that is our use case. And so I guess for that, I'm just going to start brainstorming on a text file here. So extra info needed for the crypto fiat trade use of a BP. And some of this we can actually just go and look at the burnable payment itself and see how I worded this. Well, first of all, sort of implicitly, I had a fee included in here because the request was to deposit half an Ether, and although it's not really, well, here you can see I've put in 0.6 Ether, so there is a fee included for the worker to actually incentivize them to come. So that's one thing that we could put in here. Is one thing that, and the way I'm sort of framing this in my own mind is, what do we need to ask the user, specifically the seller? So if the seller wants to put some Ether up into this burnable payment and basically attract the buyer to put dollars into their bank account in exchange for releasing the money, what do they need to specify to actually fully define that crypto fiat trade? So one of the things they need to define is the fee, and maybe percentage we'll use. So that's one thing, easy enough. Another thing that, well, let's just see here. So one thing I specified here in the in my extra information is a deadline. So that's another thing, and I'm just sort of brainstorming. We might take some of these out, but deposit deadline. And the idea being here is that if the buyer fails to deposit the money into the bank account by, whatever it is, it's a week, 2 weeks, a month, whatever it is that the seller sets up, then the seller sort of gives it up as lost and burns the burnable payment. And again, in theory anyway, the seller is rarely going to have to burn the money, but we do still need to work out the mechanics of how and when that will work. Otherwise, the threat loses its punch, and without the threat, then the whole system, the game theory, breaks down. So, oh, and then another bit of information here is my bank accounts, and so that's another bit of information, is that where, which bank accounts is the seller able to accept a deposit into. So banks, I guess. Let's see if is there anything else here. Oh, email. We need the email because for two reasons. One is that if we include the email and encode it into our contract, then our notification server knows who to email, and also the seller can contact the buyer can contact the seller and ask for their bank transfer information, like their routing number, etc., their name, whatever you need to deposit the money. That might be it. Let's just look back over here. I specify here where to get the price, but when we design the server, we can sort of design that into the UI, and just have the server assume a specific price oracle. I mean, I don't really know if you'd really call it an oracle, but that's the role it's going to be playing. Since we have a server that's going to be sort of managing this whole process, we'll just choose a specific mechanism for determining a price on a specific time, and just use that for what our system, how our system determines the price that needs to be put in the bank account. So I think that that's all that we need. Let's see. Whoops. Yeah, I think that's all the information we'll need to communicate. So I'm going to go ahead and cross that off. If you guys can think of anything else, and I might think of other things too and add it to that list, but for now I'm going to cross this off. Move on to number 3. We only have about 15 minutes left, so we probably won't get into actually developing any solidity in this stream, but we can start talking about what the contract is going to be, what we'll need to design into the contract. So as I said, we're going to have to encode more data, and we just went over and sort of determined what that data is going to be. And it's also going to secure a fee for our server. So I'll just go in here, and I could add it to this file. I am going to not do that. I'm going to go ahead and just make a new tab here. File name. That's another thing. I need to think of a name for this project, because right now I keep saying decentralized crypto to fiat trade mechanism, and that is a mouthful. What does that turn out to be in a acronym? Decentralized fiat to crypto trade mechanism. Ooh, that's ugly. That's ugly as fuck. Diftum. .sol. I'm gonna just do that for now. It doesn't really matter. It's just what it's gonna be called in here. That's fine. So pragma. I always forget the syntax of this first line here. It's just wonky. That caret always throws me off. And I've never actually included a contract before, so I don't even know the syntax for including. Syntax, solidity, include. It's probably pretty easy. There we go. Import. Okay. So I'll put it in here. It probably won't be able to. Well, maybe it will be able to find it, because I guess it's all in the same thing. Of course, this one thinks. Can I change that? Please let me change it. It is not letting me change it. Come on. Well, all right. I'm not too worried about it. So here, I'm not going to say import ballot.sol. I'm going to say import Burnable Payment.sol. And that'll give me an error. But that's okay, because I'm probably not going to be compiling this stream anyway. And contract, again, that is just an ugly name, but I don't have anything better. We'll have to think of like a cool, catchy name for that. Please, if you guys have any suggestions or just want to brainstorm, shout out suggestions in the chat. But anyway, so now a question here is whether we want to inherit a burnable payment and make a contract that inherits all the burnable payment stuff and we just add a few fields to, or do we want to make a contract that simply calls the creation of a burnable payment and tracks the address of it? So those are the options, and I'm not really sure which one to go with. Another thing that's sort of bouncing around in my head is that when you look at the burnable payment here, all these statements, all this text here, it's actually pretty cheap to do this, and that's because this data is not really being stored in the contract. It's being emitted as an event, and if it was actually being stored on the contract, it'd be much more expensive. So if I were to decide, well, okay, this is going to, how do you inherit? I'm actually not even sure. Maybe it's a colon, but whatever the syntax is, if I were to inherit the burnable payment, and then add in more fields to track all of our extra info, we would have to pay for the storage of that. And pay more for the storage of it anyway. I mean, unless we emitted it as events. But if we're emitting it as events, I guess that impacts our decision whether to inherit or just use the burnable payment. So I don't really know there. Get this in our chat. Yeah, you could use IPFS, but then our client has to connect to two different systems, and IPFS is kind of slow. And you know, I personally am not that convinced that IPFS is a long-term viable solution, because you're storing data on IPFS and no one's being paid to keep that data. It's free to use, which is nice, but the easier it gets to use, the more people are going to be storing data on there, and like, who's storing that data? Who's being paid to store that data? I think a failure of IPFS is that it's not a blockchain. There's no inherent incentives to the system, and but I guess I could be wrong. It just I'm just uncomfortable building in dependency to IPFS. I mean, I guess what it comes down to is I'm not personally convinced that IPFS is a viable long-term solution, but even aside from all that, if we can build a system that only uses smart contracts and still works, that's going to be a more stable project than a client that uses both IPFS and Ethereum. I mean, especially we're not storing large amounts of data, so... Well, yeah, so events, they're emitted, and they're sort of stored. It depends on, so some nodes store all event data. Those are called archive nodes, and they take like 500 gigs of data or something like that. So when you emit an event, you do that knowing that it won't be stored on all the nodes. It's not really part of the blockchain. It's part of the history, but it's not really stored. Certainly not. It's not part of the EVM state, I guess. They are just stored on the blockchain, sort of as metadata, and it's metadata that nodes often just ignore and prune out of their logs, because otherwise it's just a huge chunk of data. And so when you emit an event, what you're doing is you're sort of saying, this data is not essential to the EVM logic. Your contract doesn't ever react to events or make a decision based on events, and so it can be completely ignored by a node that just wants to maintain state and mine blocks. And but by emitting events, you still sort of leave them out there for any node to watch for if it's interested, and then includes your own specially configured node. You can configure your own node to watch for events from a specific address, and in that way your contract can talk to your client interface, but you still don't have to pay for you don't effectively have to pay the whole network to keep track of it, because you don't require the whole network to keep track of it. You just need the network to keep track of the state and make sure that the EVM is functioning correctly, which your event logs don't actually impact. So that's sort of the weird role that events play. Okay, so again, and we only have 6 minutes left, so I guess what I'm going to do here is I'm just going to add some comments with some questions that are bouncing around in my head. So I guess the first question, while we're on the subject of events, is where and how do we store all the extra data? And I'll just go ahead and copy. This is the extra data we need. So where do we keep this data? Where do we put it? And my initial thoughts on there are emitting it as an event would probably be fine because I guess we got to think about, who do we expect to use this data. First of all, the fee, deposit, deadline, banks, and email, none of that's going to impact our contract logic. In fact, the burnable payment itself, the logic is going to be completely unaffected, which makes me want to lean towards not inheriting and modifying the burnable payment, but rather just creating the burnable payment and tracking it. In fact, I'm just going to put address BP, although owned BP. So that's probably how I'll do it, and I guess it's a public thing. So our our contract here is going to create a burnable payment and sort of track it and sort of almost own it in a way. It'll be the burnable payment that is either controlled by this contract or controlled by the same person who's controlling this contract. I guess it'll be controlled by our overarching contract here. But in any case, none of this this information really affects the logic of the burnable payment. What it changes is the human readable request and sort of the data that both of the agents of this game that are engaging in this game theory. It changes the information that they enter the game with. So the seller has, for example, he specifies his banks. Maybe it's like, we'll say it's Credit Union 1. That's one of my banks. And that information is useful to the seller. It would also be useful to the buyer because that gives them information about whether or not they can even complete the request, knowing that if they don't complete the request, then I'll burn the money. So I'm tempted to, maybe we'll have a, we have to have a constructor. That's another change between the older version of Solidity and this newer version, is we actually call it a constructor. So we'll probably take a lot of the same arguments from this, although maybe not even as much. For now, I'll just take all that and copy it over. Well, I'm just gonna, just for, whoops, I didn't want to do that. Just for now, I'm gonna say, and let's see, what was I getting at there? This constructor will probably also take information about the email. So that would be a string, I guess, a string email. And then a uint fee, although again, I'm hesitant to really take these in as Solidity variables. I mean, for one thing, this fee would have to be submitted as an integer. I mean, a big integer that would then represent a percentage, which would add more logic to our smart contract. So actually, probably what we would do is just say something like this, string offer details, like that, and then that will be a JSON encoded string. And then inside this constructor, we would just emit a specific event, which we could even maybe define really quick. And so before defining it, what we're going to do is this constructor is, well, first it's going to create the BP, the burnable payment. And then it's also going to emit an event, which we expect to be picked up by our server. So that event is going to be something like maybe offer created, and again, that's going to have a lot of the BP. Well, we could probably just give it the address of the burnable payment, or I guess we'll have to think through what arguments are going to be here. But one of the arguments for sure is going to be offer details. And so here we would emit the offer created with whatever other arguments we have in here, as well as the offer details, like so. And so the constructor is going to take a string of offer details, and it's really, I mean, it's almost like saying where it goes in one ear and out the other. As far as the contract is concerned, the offer details doesn't even matter at all. the only thing it's doing is it's taking that string and then emitting it as an event, and then our server can pick that up and actually display it. Anybody who's watching this can also look for that event and get that information. We might optionally later on actually store it as a string, like so, and then whoops, and then put a underscore here to differentiate, and then actually store that. So that's an option that we have. And the only reason I am really even thinking of doing that is that that will make it to where any client can just get this, especially, so if we make this a public, of course it'll automatically generate a getter, and then our Web3 code can just get that, that string of the offer details if we actually have it as a member here. So that will sort of make it easier on a client who maybe wasn't watching the Burnable Payment for the whole history, or our DCF, man, I need to change that name. I hope to have a different name by next stream. But anyway, if a client's not watching this whole process from the very beginning, then they will sort of have missed the emitting of this event here. So we might choose to keep a string of the offer details in the contract, which will increase the gas cost of this call specifically, but it will make it easier to design an interface around it. So that's an option. I'll just comment it out for now, but it is in there. So, all right, well, okay, it's 19:01. I started a few minutes late, so I guess I can go a few minutes longer. But that you know, I don't know what else I could really get into without marking a lot more time to spend on it. Well, I guess one more thing we can talk about, and that would be useful just to get this overall design here done, is that this overarching contract is doing two things for us. For one, it's creating this burnable payment and sort of capturing this information for us more easily, but it's also going to be capturing a profit for our server. So not only does it create the burnable payment and it emits the event, but it also is going to send a fee to our server, which is really just going to be transfer some amount, and you know, this fee amount we would have to think about, is that just going to be a flat amount every time? And then if it is a flat amount, when you're constructing it, we would have to build the we'd have to build the interface to make it clear that if they're going to pay, if they want their offer to be for half an ether, then they're going to have to actually submit a little bit more than that to pay our server to do that notification process. So that's the other thing our overarching contract here is going to have to be. Yeah, so David puts it probably much more succinctly than I did. So earlier, as to Seiron's question here, yeah, events are permanently on the blockchain. Yeah, so they are part of the blockchain. I misspoke. I was saying they're not part of the blockchain. They certainly are part of the blockchain. They're part of that immutable history that will exist for as long as there's a single Ethereum user, miner, I should say. For as long as there's a single Ethereum miner, the blockchain will exist, and part of that blockchain will be the event data. So it'll be there forever. It will never go away unless all of Ethereum effectively goes away. But as he said, they aren't part of the current state. And that has to do with the EVM and the state. Those are sort of related terms there. EVM stands for Ethereum Virtual Machine. And when we're writing contract code, all this code is executed in the EVM, in the Ethereum Virtual Machine, and it has a state. And so when you define an event, and when you emit the event, that does not get added to the Ethereum virtual machine, because the virtual machine doesn't care about that. It does not get added to the state, but it does get added to the blockchain. So that's a very good point that David has made there. And yeah, so because they're not part of the EVM state, you can't just go to the EVM and say, hey, what's that event log? You need to actually search through the blocks of the blockchain to find it. And as you said, that's why they're slow to find but cheap storage options. They're cheap because you're not putting it on the state machine, but they are slow to find because you might have to sort of iterate through the blockchain to actually find where the data is stored. Yep. Okay, cool. So yeah, I think we'll end there. We didn't get to any real Solidity design. This is sort of just more of a pseudocode, but I think I've demonstrated sort of what this overarching contract is going to do. I need to find a better name for this. I guess I can say SellOffer Manager just for now. That gets a little closer to what this is actually doing, but we're going to be, this thing is going to create a burnable payment. It might not actually, we might not even, so here we have, as I said, we have the burnable payment and the factory. All this factory does is it just allows us to create a burnable payment. It adds it to this list of tracked BPs. That might not even really be necessary. This contract here might just serve as the factory contract. We don't maybe even need to use the factory contract at all. We can just create a new burnable payment. We can just effectively copy this line here. In fact, I might as well just do that right now, just to get it over here. And I'm sort of talking myself into this at this point, but when we create the BP here, we'll just do this. We won't need to actually call the factory contract. So earlier I said that there's going to be 3 contracts involved: the burnable payment, the factory, and our higher level contract here. But really, let's just take out the factory. There'll just be 2: the burnable payment and our SellOffer Manager here, which will directly create the burnable payment here. Okay, cool. So okay, so it's Thursday today. I think that tomorrow, well, there's two aspects of the project, as I point out in my my SketchUp here. So we got the server and the contract. So we got 2 things to design. The bulk of our work is going to be in designing the server. Our contract here is already sort of done. I mean, we'll have to, obviously this is not going to compile, but it's not going to be too complicated. We just have to create the burnable payment, which, I mean, this line is almost done as it is. We just need to actually be able to store the address somewhere better. And we emit an event, and then we transfer a certain amount to the server. I guess we still have to determine what that fee is. Is it going to be a flat amount? But then this contract will be done. So we'll probably finish that out fairly quickly in tomorrow's seminar. And then we'll start getting into designing the server. And we're going to use David's help for a lot of that. But yeah, so that's tomorrow. We will get into the design of the server. We'll finish out all the contract work. And then we have a whole extra week, the last week of our Academy session here. Will be focused on really just entirely server work. So that'll be a sort of a departure from what we usually work on, because we usually work on JavaScript interfaces, which has nothing to do with the server. But this time, because the email notifications are such an essential part of this, that's what we will tackle first. And that'll all start with just having a server actually watch for these events that we're emitting, and sort of have a curated list of all of these sell offers. In fact, this isn't, I'm just going to take out this manager. It's really just a sell offer. Yeah. Another note that I could make is that, as I said, I'm using the newer version of this burnable payment, which allows a worker to start the payment. And so what we could do later on, if we have time before Friday of next week, is we could actually make another contract called a buy offer. That does the same thing, but actually creates it as the worker putting his service deposit in first, and he's actually offering to buy some Ether with his US dollars, and he's putting his service deposit in there to begin with. So that's another option we could do, and then our decentralized crypto exchange mechanism could allow sort of that mirror imaging of, if we only do this first contract here that has a sell offer, then we're sort of relying on the seller to initiate the process and wait for a buyer. If we implement this second bit here too, then we can reverse that process, and we can make it to where the buyer who has US dollars and wants crypto can actually initiate that process and then wait for the seller to come along. So we can do that in both ways. I'll start with the sell offer here because that's going to use the burnable payment in a mechanism that's more tested and more familiar. But yeah, okay. So that's about it. I know I've said I'm done about 3 times now, and then I launch into some other explanation. So I'll just end it here, and I'll see you guys tomorrow, where we finish out the development of this contract and start getting into the server design. Thanks, guys, and I'll see you next time.